Hi everybody, hope you're doing well. If you're watching this video, that means we're at the end of week 3 of the 4th marking period. This video is going to walk you through the second of the factoring strategies you are going to learn in this unit. Previously, you've learned how to factor things apart by finding a greatest common factor. Now we're going to look at something called factoring trinomials. So you're going to see with what you're going to learn here, all of these follow the same pattern. So we're going to talk through and explain the pattern with all the text that you see at the top of the screen here. And then we're going to go ahead and do some examples here that will follow the same pattern over and over again. So, quick review here. The word trinomial, which you learned in the first lesson of the marking period, is an expression that has 3 terms. Now, for what we're going to be learning right now, we'll see trinomials with some different components a little bit further in the chapter, but to introduce this topic itself, they are going to be in this format that you see up at the top of the screen. Something x squared plus or minus something x plus or minus something. Ax squared plus or minus bx plus or minus c. We'll see other trinomials down the road here that have some different powers and things like that, but ultimately 3 terms in that order. What we are going to be looking at is how to break these expressions apart. Now, as you'll learn when you get into Algebra 2, there's a little bit more to this particular factoring pattern, but to make things kind of easier for what we're doing here in Algebra 1, what we do is we limit everything to that this front a value right here is a 1, aka the front term of everything we're going to deal with is just x squared. Otherwise, we'll use some other factoring strategies to pull that apart. But for what you're going to see in this strategy today, everything is going to be x squared plus or minus something x plus or minus something. So, in order to factor apart trinomials, the basic gist of it is this. You must determine 2 values that multiply to c and add to b at the same time. So we're going to go through all these expressions. They'll have some numbers in for the b and the c. We're going to figure out what multiplies to c, and then take whatever numbers multiply to c and see, do they add up to the b value that we're supposed to get. So, with a lot of this, there's not really a name for this strategy. I tend to refer to it as trial and error, because a lot of what you're doing is you're just guessing and checking different combinations that multiply and add together. You're going to see there's some smart ways to do this, and for those of you that are really quick with your mental math of your basic facts, you're going to see a lot of these numbers have a lot of the same patterns, and you'll come up with these factors here hopefully pretty quickly. If you're not as strong with it, we'll talk about a couple ways here that you can try to work through these here so you're not spending forever trying to figure out how these break apart. So let's talk about how these ultimately factor apart. So you can see the example that's given to you, x squared plus 4x plus 3. In order to factor that apart into 2 separate factors, again, the goal is we want to figure out what multiplies to c and adds to b. The b value is always with the x, the c value is always the constant, so it's just a number without a variable. And that'll be the case every single time we work through these. So I want to figure out what 2 numbers multiply to c, aka what multiplies to 3, and add to b, what adds to 4. So, some numbers, there won't be a lot of things to guess and check. So just going through in your head, well, what multiplies to 3? Well, first thing that comes to my mind is 1 and 3. So if I quickly take 1 times 3, okay, well that checks out to 3. What I then do is take those same 2 numbers and say, okay, well does it add up to 4? Well, we know 1 plus 3 is 4. Well, that's good. That checks out. That's the only number pair that satisfies this. And what's nice about these is when it comes to these factoring, when it comes to factoring these apart, you're not going to have to think of, well, could there be other number combinations? It's only going to be one number combination that'll break these down. So, once you figure out what multiplies to the c and adds to the b value at the same time, that's when you can write out your factors. So, what ends up happening is, to split apart x squared plus 4x plus 3, you take the 2 numbers, you can see them here in the parentheses, and basically you're putting them with an x. So what happens is when you factor, the x squared breaks apart into an x and an x. So those get separated into their own factors. You then put the 1 and the 3 in, and you put the appropriate sign with those numbers. Since they were both positive, we put plus signs with them, and that's how you come up with those two factors. That's all you have to do to split these apart. So it's, again, just knowing some of your basic facts. Sometimes you're going to get some number combinations that are a little bit different, but ultimately it's not going to be anything that's too out there. You're not going to have to worry what multiplies to like 480 and adds to 72 or some big numbers like that. But you'll see as we go through these here the different number combinations that exist. Now, ultimately, if you want to check if your factoring is correct, you can multiply your factors back together. So we talked about that with the factoring out of GCF lesson that you went through last week. If what you multiply back together becomes the original problem, then your factoring is correct. So you can see here with our example here, if my factors were x plus 1 and x plus 3, we distribute them together. X times x gets me x squared. X times 3 is 3x. 1 times x is 1x. And 1 times 3 is 3. You combine your like terms together. I end up with the exact same problem I started with. That's how you know that you factor correctly. So again, you don't necessarily have to show that check every time that you do this or at any point. But if you're not sure if you have the right number combination, again, factoring and distributing are opposite operations. So ultimately, if you're not sure if what you factored is correct, distribute it together and see if it goes back to what you originally had. So what we're going to do as we go through these here is we're going to look at each problem, figure out the same two things. What multiplies to the C number and adds to the B at the same time. Once we do that, we're going to be able to write out our factors pretty quick. So if you are not the greatest at figuring out, well, what combinations I can come up with, I will tell you the easier thing of the two to do, don't try to figure out what adds to B first. That you can come up with an infinite amount of numbers that'll add up together. However, if you think about what multiplies to the C number, it's going to limit how many number pairings you come up with because only so many things will multiply together. So let's talk about number 1. We have x squared plus 10x plus 16. So again, the B is the number with the x. The C is your constant that has no x attached to it. So the goal of this problem is this. I want to figure out what multiplies to 16 and adds to 10. Now, what I'm showing you here, again, you don't necessarily have to do, but for those of you that are not great with your basic mental math, this will really help you organize your thoughts and come up with the right number pairings so you're not constantly stuck on the same two wrong numbers over and over again. So, again, first thing I want to do here is figure out what multiplies to 16. So, let's say 4 and 4 come to mind. We know 4 times 4 is 16. Awesome. Now I'm going to take those same two numbers, add them up. So we know 4 times 4 is 16, so I guess I'll write it up this way. Now if I take those same two numbers and add them up, I get 8. Well, that's a problem. I need it to add up to 10. So what that means is 4 and 4 don't work. So I'm just going to go ahead and X them out, cross them out. That's a bad pairing. So you need to think, well, what else multiplies to 16? Let's come up with 2 and 8. 2 times 8 is 16. Now let's add them. Well, what's 2 plus 8? Hey, look, it's positive 10. Ding, 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 we've got ourselves a winner. So what that means is once you figure out the one pair of numbers that satisfies both of those things, multiplying the 16, add the 10, we can write our factors. So again, that x squared splits apart to the x and x. We'll put a positive 2 with one of the factors and a positive 8 with the other. My factored answer would be x plus 2 times x plus 8. And that's my final answer. And again, I can check to make sure that it's right by distributing it back together. Again, you can certainly try that and check me on that, but I promise you those are the two correct things that we factored. So again, that strategy as we go through, you can certainly do that and list things out. I'm going to more just talk these out and come up with the correct pairings. But when you're working on your own with this, certainly I suggest drawing the little table. If you can come up with them without drawing the table, you certainly don't need to show me that with any of these. So let's talk about number 2. X squared plus 12x plus 35. So B is 12, C is 35. So I want to figure out what multiplies to 35 and adds to 12. So, what multiplies to 35? First thing that comes to my mind is 5 times 7. Okay? So, multiplies to 35, adds to 12. I think of 5 times 7. That gets me 35. So now I'm going to take the 5 and the 7 and add them. Hey, look, I get positive 12. That's great. Right off the bat, I've got my answer, which means I have my factors. So again, x and x, positive 5, positive 7. My final answer would be x plus 5 times x plus 7. We are going to use the same pattern here for all these trinomials. What multiplies to c adds to b. It's the same pattern over and over again. The only thing you have to be careful of, so if you notice these first couple examples, they were great because they all were positive. When we start throwing minus signs and those negatives in place, you do have to pay attention to them because it's really easy to come up with a number of combinations you think work, but if you ignore the signs, they might be wrong. So we're definitely going to talk about some problems here that have got some minuses involved. If you think you got a general gist, again, at any point, hit the pause button. Try a couple of these problems on your own. See if you can come up with the right pairings. Fast forward. If they match what I've got, awesome. If you want to just keep watching and hear the explanation, please feel free. So, let's look at number 3. We've got ourselves x squared plus 12x plus 27. So again, what multiplies to c adds to b. I need the two numbers that multiply to 27 add to 12. The two numbers that do that are 3 and 9. 3 times 9 is 27. 3 plus 9 is 12. Therefore, this will factor apart into x plus 3 times x plus 9. Number 4, x squared plus 21x plus 54. Two numbers that multiply to 54 add to 21. First two numbers that come to my mind are 6 and 9 that multiply to 54. But the problem is if I add 6 and 9, that gets me 15. So that's a bad set of numbers. Let's think, what else multiplies to 54? 27 and 2 multiply to 54, but when I add that up, that gets 29. So this is an example here where there's a couple pairs that multiply to 54, but you might need to think this one through. Other pair that works, 18 and 3. 18 times 3 is 54. 18 plus 3 is 21. So I can write this out as x plus 18, x plus 3. And that is my factored and final answer. One other note I'll make about this that I should have mentioned at the beginning. When you write out your two factors, it does not matter which goes first. The beauty of having these two factors written like they are, it's, again, written as a multiplication problem, which means order doesn't matter. As long as you have the correct two numbers with the correct signs, you're in good shape. So, like for number 4, x plus 18, x plus 3, you could also write it as x plus 3 times x plus 18. It means the exact same thing. So again, order doesn't matter as long as you have both the correct values. All right, now 5, 6, 7, 8, we're going to start seeing some minus signs, so we really need to pay attention to what we're doing here. So, x squared minus 8x plus 12. I need to figure out what multiplies to 12 and adds to negative 8. So, if I think what multiplies to 12, 6 and 2 come to mind pretty quick. So we know 6 times 2 is 12. If I add up 6 plus 2, I get 8. Not quite what we're looking for. We need it to add up to negative 8. So, let's think here for a second. It has to multiply to a positive, but add to a negative. Well, in order for it to multiply to a positive, both numbers should be positive, or both numbers can be negative. If I multiply two negatives together, I get a positive. So if I, let's say, make the 6 and the 2 both negative. Negative 6 and negative 2 multiply to positive 12. If I add negative 6 plus negative 2 together, I get negative 8. So sometimes it's just a matter of flipping signs around with the numbers that you have. So ultimately, though, I need to account for the fact that the b value is a negative 8, not a positive. So if you see a negative in your problems, that means you're going to see a negative somewhere with the two numbers you need to come up with. So what satisfies this is a negative 6 and a negative 2. So my two factors will be x minus 6 and x minus 2. Make sure you include your minus sign with the numbers because, again, you needed them to make this set of number combinations work. So again, we're dealing with some negatives. Make sure you include that as part of your factors. Number 6, kind of the same idea here. So what multiplies to 30 and adds to negative 13? So if we think what multiplies to 30, first thing I think of is 5 times 6. But if I add them, I get 11. So that's pretty wrong. Let's try 10 and 3. If I add them, I get a positive 13. That gets me really, really close, but I need to be negative 13. So how can I fix that? Well, let's make both numbers negative. So again, both numbers negative. When I multiply two negatives, it still gets me positive 30, so that's okay. When I add them, that gets me a negative 13. That checks out. My two factors would be x minus 10 and x minus 3. Now let's look here at 7 and 8. Again, same idea. We just have minus signs now in some different spots. Again, we're going to talk them through. Again, these tables that I'm drawing now, in my own head, I probably wouldn't use these. But again, if you need it to help stay organized, again, you can feel free to write them out and be my guest. If you don't need them, that's cool too. Let's talk about 7. The goal is let's multiply to negative 48 and add to negative 2. So let's talk about multiplying to negative 48. If it has to multiply to a negative, that means one number's got to be positive, one number has got to be negative. So, first thing I think about multiplying to negative 48 would be some combination of 6 and 8. Again, it has to multiply to negative 48, so one of those numbers has to be negative. So I'm going to try negative 6 times 8. That'll get me negative 48. If I add those, I'll get positive 2. Close, but not quite what we're looking for. The fact that I have the right digit but the wrong sign means let's take the two numbers I came up with, let's flip the signs. Let's make the 6 positive and the 8 negative. So again, make a little bit more room here. Again, if I multiply those together, 6 times negative 8 gets me negative 48. If I add them together, I get negative 2. So again, if I need to multiply to a negative, basic math rule, one number has to be positive, one number has to be negative. When you're doing your trial and error, sometimes you're going to get really close, but might need to flip signs around. Again, the signs do matter with the numbers you're trying to come up with, because it has to match the combination exactly. So, 6 and negative 8 work. That means one of my factors will be x plus 6, because the 6 is positive. The other will be x minus 8. And last but not least, number 8. Now, if you're looking at this going, well, why did I label a B? I don't see a number there. There is a number. So, if I have just a plain old x, I've got myself an invisible 1. Do not call that 0, because 0 would wipe out the x term. There's an invisible 1 there. So if you see just a plain old x, some people get really stuck on these problems here. There's just a 1 that's there. So my goal here is to multiply to negative 42 and add to positive 1. So when I think of negative 42, I think of, first and foremost, let's try 6 and negative 7. So when I do that, 6 times negative 7 is negative 42. If I add them, I get negative 1. So again, really close, but not the answer I'm looking for. Again, when I look at the addition, I see, hey, I'm really close, right digit, wrong sign. So we're going to take the two numbers here and flip the signs. I'm going to make the 6 negative, I'm going to make the 7 positive. Again, negative times positive gets me a negative 42. Negative 6 plus 7 gets me a positive 1. That tells me I've got the right number combination, which gets me the right factors here of x minus 6 and x plus 7. So again, with this strategy here, it's a lot of trial and error. Some of you are going to blast through these really quickly because you're good with your math facts. Some of you are going to make some goofy mistakes if you try to do them too quickly because you'll scramble signs. do take your time in coming up with the numbers, especially when you start seeing minus signs like 5, 6, 7, and 8, because that will change how your problems work if you accidentally put the signs in the wrong order, or if you forget a negative, or whatever the case may be. So again, moral to this lesson today, your factoring expressions apart, they have three terms: multiply the C, add the B, see what you get from there. So your assignment that goes with this here is an IXL. Again, staying in level K like we always have, we're looking at AA4. That is your graded assignment for this, and as always, get it to an 80. Follow whatever formatting it is telling you to put in, and again, it should look exactly like what you're doing with all the problems that we just did there in the notes. So as we move forward from this, we're going to apply zero product property to what we just factored here. Again, all these skills are going to build on each other. So make sure if you have any questions, you get a hold of me, and we can certainly talk more of this out. So, like I say all the time, any questions, get a hold of me, shoot me a message on Schoology, send me an email, or we can set up some time on Zoom. Come by my office hours, and I'll be more than happy to work with you and get you straightened out with all this stuff. Okay, keep up with your assignments. Those of you that have been turning stuff in on time, great. If you've been a little bit behind on things, keep trying to play catch up here. Again, I can be flexible with things. Just make sure you are getting caught up with your work, especially because of the stuff in this unit. It all builds on itself. So make sure, again, you're taking your time with these things, you're understanding what you're doing, and you're reaching out to me if you're not. Otherwise, stay safe, stay healthy, and we'll see you next time.